Hello all. Welcome back to software maintenance class. In this class, we are going to see what exactly is a reverse and re-engineering. So uh, let us start first with what exactly is reverse engineering. We can we can start with an example. Let's assume that we have written a project using a Java programming language. Now the project is done. It's working properly. However, by accident, we have deleted the source file, which was there uh, in, in our folder, which we have used our file and this file to execute our program. Now, the thing is how we are going to handle our project. What, how we can. So as we can see, the source file has been deleted accidentally. In this case, the code or the entire program which was there, we cannot execute that particular program because for executing the program, we need the source file. So in this case, it turns out that we can use uh, the process called reverse engineering, and we can try to get back the deleted code for the project which we have written using Java programming language, or maybe using any other programming language. So before we go into what exactly is reverse engineering, let's see what this waterfall model of software development is. I assume that you know about this waterfall model in more detail. However, I will just tell you how it. I will just give you a brief information how it works. First we capture some requirement from the customer, based on which we prepare software requirement specification, and we also call it SRS. And then we come into the design phase. Based on the SRS that we have gathered, we start doing the coding, and we start doing the we design the overall architecture, the high level architecture for the software, which was which we are going to document these things in software design document. We also call it SDD. And in the next phase, we are going to implement, maybe using some programming language. We are going to start coding, and once the program runs, once we have written the code, and for the entire software, we perform the testing. uh, in this testing, we check the quality of the product which we have designed, and of course the next phase comes the operation and maintenance, in which once the product has been delivered, we try and if there is any fault in the product reported by the customer, we try to fix those things in maintenance. So this is basically a simple step which we follow in waterfall model. However, this is also called as normal forward engineering, in which we start by from capturing the requirement for a particular software, and then we go into design, and finally we start writing some code, and we finally by the end of the schedule, we have a software which is going to have certain behavior in the sense it is going to perform certain functionality for which the entire software was written. However, if we talk about reverse engineering over here is goes it starts from the backside of waterfall or forward engineering. We are going to have certain behavior with us. Now, based on those behavior, we want to get into maybe into source code, or it maybe we want to get into the design or requirements. So it will depend what actually we want to get back from doing this reverse engineering, and it will also depend on the product, which on the scope of the product as well as scope of the company which is doing this reverse engineering. So reverse engineering can be done for getting the source code of the deleted program, which we have seen. It can also be done to get the entire design of the software. And of course, it can also be done to get to capture what were the requirements which led to this particular software. So this is exactly what is reverse engineering. Like I said, we are going to have an old system, and we don't want to build a new system from the scratch. What exactly we are going to do here is we are going to perform reverse engineering, and we are going to start from this old system to get an abstraction of that particular old system. So so the thing is, reverse engineering, with the help of reverse engineering, we are trying to understand, and we are trying to modify this existing old software system, and the basic purpose is to identify and recover program requirement, and maybe the design requirement information from this old system. So the abstraction basically over here is the process of ignoring certain details in order to simplify the problems, and to facilitate the specification, design, and of course implementation of a system to proceed in a stepwise manner. So once you have this the abstract system available from the old system, then you perform the same waterfall model, or maybe any other software development lifecycle process you can follow. So basic idea is you are going to perform software forward engineering, and you are just going to re-implement, and you are going to build the new system. So what exactly is reverse engineering? So reverse engineering, like I said, is basically we are is a task which we perform to understand and to modify the existing software system, and it includes various activity that is done to determine basically how a product works, to learn ideas and technology that were used in developing that product. Moreover, reverse engineering can also be done at many levels. Like I said, it can be done to get the code, get the high level design, get the documentation, get the requirement information that led to the particular software. However, we can strongly say the reverse engineering generally belongs to software maintenance phase. So why actually we need reverse engineering? So if you see the first example, it talks about recovery of lost information. So lost information in the sense, if if the product code has been deleted, for example, you want to get that code back. So in that scenario, we can perform reverse engineering. And of course, we can performing reverse engineering means we are going to have proper system documentation once the reverse engineering has been done. And it is also going to assist in maintenance thing, because now you don't have to build the whole system from the scratch. You have a high level abstract system with you because of this reverse engineering. Now you know how exactly the software or the product works, so you can start building the product from there with the help of those information. So the thing is, we can identify the side effects and anomalies also with the help of reverse engineering. Migration to another hardware software platform. So if there is any migration from let's say from one operating system to different operating system, or from one software platform to different software platform, this, or maybe one hardware system to a different hardware system, in that scenario also we need reverse engineering. And finally, the main use of reverse engineering is it facilitates software reuse. You don't have to build the whole software from the scratch. You can just use this abstract concept, and you can build the software based on those information. So why actually do we need a reverse engineering? So there are several benefits associated with a reverse engineering. For example, the maintenance cost saving. So cost reduction when basically when you create a new product or a new function and you deliver it to market, it is always cheaper if you have performed reverse engineering, because you have not started from the beginning. And in that scenario, it turns out that reverse engineering is very beneficial for saving the cost of the whole development life cycle. Quality improvement. Now you know exactly what were the problems associated with that particular software. So you already know if you're going to follow these things, you're going to have these challenges or anomalies. So you don't do those things. Rather, you take different aspects to improve the product itself. Competitive advantage. So this is something which the many companies they do. They actually they don't they reverse engineer the product which is there in the market, and based on that they start checking what were the methods, what were the code, what were the documents used for manufacturing that product, and based on which they can get the information and they can release their own product, next version of their own product faster with more enhanced features. So this is reverse engineering is also done for competitive advantage. However, it turns out that it is doing this thing is illegal in many countries. Software reuse facilitation. So you can also reuse the software, because now you have the abstract overview of the old legacy system, or maybe the old system. Now you can build a product based on which, and you can enhance the features of course the features, and you don't have to start doing from the scratch. You can just you have now you have a path. You can follow that path, and you can achieve a good quality software out while once you are performing this reverse engineering. However, there are multiple difficulties when you perform this reverse engineering. For example, there can be a gap between the problem and solution domain. The reason behind this is the problem which we have identified, it's not exactly the same which on which the product which we are doing this reverse engineering, and the solution by the end which we are going to provide, it may differ from the problem which we were thinking to work on it. There can be a gap between concrete and abstract form. Maybe the abstract form which we have collected, there is no similarity between the product which we want to build and the abstract phenomena which we have captured during while performing this reverse engineering. There may be the gap between coherence or disintegration, and of course there can be some gap between hierarchical and associational methods. So these are the different possibilities or different difficulties which are associated with reverse engineering. However, there are different scope and task of reverse engineering. For example, we can perform redocumentation, and we can and redocumentation is done, and document generation is one of the scope or the task of reverse re-engineering. Recovery of design approach and design details at any level of abstraction. So basically, there are three different levels of abstraction: high level, intermediate, and low level. So we can recover design approach. Means we can recover overall architecture or the design, or it maybe we can recover the information about different components and the modules of the system, or we can also recover the machine level code of the system that were used for designing the product. And we can also identify reusable components and components that need restructuring. So reusable components can be identified, which we can directly reuse. And of course, we can also identify different components which we can restructure, and we can make some changes in it, and we can use it in our new product. Different We can recover business rules which were associated with the product, and because of this business rules, it is very easy to design the whole product. uh, we can also understand high level system description. So so you don't have to understand from the whole system, from this from for means you don't have to do a lot of engineering tasks for understanding a system. So once the reverse re-engineering has been done on a particular product or on a particular software system, it is very easy it will be very easy for you to understand the high level system description. So these are the different scope and task which we are going to perform once this reverse re-engineering process is done. So discovery of abstraction, like I said, abstraction level refers to the different levels of detail and complexity that we are going to use to represent a software system or a component or maybe or a object that is being used in that particular software system. So discovery of abstraction in large system we are going to do, and why this discovery or why we want to achieve this abstraction is first is for the maintenance purpose, second is for the evolution purpose, and third is for re-engineering purpose. So it will be very beneficial if you have this high level abstract detail of the legacy or the system which you have performed reverse engineering, because by the end you don't have to, now you understand the product, you understand the components, so performing maintenance will be very easy in that scenario. If you want to perform some evolution, means you want to change certain detail, if you want to perform some changes in that particular software, you can all this abstraction will be very helpful. And of course it is going to be helpful in re-engineering, because in re-engineering you have the detail and you can start building the product from there. What are the different levels of abstraction? So this level of abstraction can be on application, function, structure, implementation. So when we talk about application, we are mainly focused on application of in terms of concepts, the business rule, the policies. So the application means the actual product which we are going to hand over to the customer. So in this application, it mainly talks about the concept, business rules, and the policies which were used during the design of the product. Second thing is the function. What are the different functionality that the product performs? So this functionality can be in terms of non-functional requirement as well as some functional requirement. What are the different data structures or the structures that have been used? Maybe we have followed some data and control flow. There are some dependency on graphs, some structure and subsystem charts has been followed, and we can also get some information about what are the different high-level architectures that have been used during the abstraction. And of course, implementation, which is going to cover what are the different symbol tables, source text, and so on. So what are the different approaches over here if you want to get into a product? So the thing is, we can perform reverse engineering, and of course, we can also perform re-engineering. So when you perform reverse engineering, it is mainly focused on design recovery and redocumentation. So you want to recover the entire design that was used to build the product. So you want to reproduce the entire the product design. It can be the high level design or the architectural means design. And by the end, you want to get some documentation from performing this reverse re-engineering for the entire system. So redocumentation is going to be done for the entire system. However, we can also perform re-engineering, in which the first phase is you need to understand the system, and in the second phase we just follow the forward engineering. So the basic difference between reverse and re-engineering is so both both the process refer to the further investigation or engineering of a finished software product, but the method of doing so and the desired outcomes are completely different. For example, reverse engineering attempts to discover how something or how the product works. However, re-engineering seeks to improve current design by investigating a particular aspects of that particular product. So what are the different applications of reverse engineering? It is mostly used when you want to modify a particular software, and this modification of software is mainly done when there is a change of environment. I mean, there is some software migration, and change of environment can be in terms of anything the actual hardware or the software on which the particular software was running. when you want to perform, when you want to redesign the software. So redesigning is very is cheaper compare with starting from the scratch, because now you have the basic ideas of how the software can work and how it can deliver the functionality that that the particular customer wants. So re-engineering is also one of the application uh, we are when of reverse engineering. Uh, the other application is design and implementation in forward engineering, that is debugging. So when you want to identify bugs during the maintenance, you can perform reverse engineering, so you can get the design and implementation information, which will be helpful in forward engineering, for when you do this forward engineering, basically for developing the product. Third is to the program understanding and comprehension. So by performing reverse engineering, program understanding understandability gets increased, because now you have the source code. So you have now you know exactly how what source code is there and how the source code provides different functionality for that particular software. It is also helpful for program visualization. So now you have the product in front of you. You have performed reverse engineering. You have an abstract level detail of that product. So visualizing the program in terms of its functionality, maybe functional and non-functional, it's very easy from if you have some information in front of you, rather if you compare some people who are starting from the scratch and writing all those information from the start. So program visualization will be there once you perform reverse engineering, and of course you can reuse the software. So if you have some old system, you can always build a new system. You can perform first you can perform reverse engineering, you can get some information out of it, and then you can do re-engineering, so that you can change certain modules in it, and you can always use that legacy or the old software system. Now, the thing is, what is data reverse re-engineering, data reverse engineering? So data reverse engineering, it mainly talks about the database or the data structures which is being used in a particular software system. And basically, this is the process in which through which the logical and conceptual schema that has been used in the development of a legacy database, or maybe set of files uh, set of files or data dictionary languages or other informations we try to get by performing this reverse engineering. So we say, for example, we say that we have some hierarchical files for which we have from which we can get relational database, and from relational database we can have this object oriented model. So the basic idea is you want to get the data relationship. What are the different data structures that were used in that particular software system, and data structure and the database that were used in that particular software system in order to design your own product. So 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 you want to get all those schemas and the logical and sorry, you want to get those all logical and conceptual schemas which were used in designing the software based on particular data. So you are also going to see different other terms which starts from re, where the first one is re documentation. So with the help of this in re documentation, basically it means you want to there is a legacy system now. You don't have any documentation available with those system, because there has been done series of changes in that system, and after performing series of changes, it may happen that you don't have the final documentation. So in reverse engineering, this term redocumentation you are going to hear very often, which refers we are going to perform documentation of every level which is needed to design the new software. And of course, we will also see this term restructuring, where restructuring means we are going to transform a system from one representation into another, while preserving its external functional behavior. Means that the internally you are going to redesign it. Maybe you're going to change the coding thing, and but the overall functionality that the system was performing earlier, it is going to perform the same functionality now also. The third is targeting. So retargeting means you are going to transform, or we are more interested in transforming or hosting, or the existing system into new configuration. So you don't want to start doing something from start. Basically, you want to perform this thing. You want to perform retargeting. Means you want to transform, or you want to target a particular portion of the system to perform some new configuration. There are other re terms associated with this. The first one is business process re-engineering. So business process re-engineering means these are basically the radical redesign of business processes, which we are going to perform to increase performance, and this performance can be in terms of cost, quality, service, and speed. We also have other things which, for example, we have this re-optimization of organizational process and structures. And apart from this, the next is reverse specification. So in reverse specification, basically we want to extract a description of what the examination of the system performs. So the basic idea is you want to extract the information that particular software performs. Uh, the second is the specification. The specification is abstracted from the source code or design description. So the next topic that we have is re-engineering. Let's see what this re-engineering over here is. So basically, software re-engineering is reorganizing. It is a process in which we reorganize and we modify the existing software system to make that particular legacy system more maintainable. So the basic idea is you want to modify the existing system. You don't want to start from the scratch. And once you reorganize or you modify the existing software system, it will be more maintainable, because the understandability and the readability of the software is going to be increased. So this is the main process, or the main task of software re-engineering. We also have this when we talk about we talk about system re-engineering. So basically, system re-engineering is restructuring or rewriting a part uh, or all of the legacy system without changing its functionality. So you want to restructure, or you want to rewrite the legacy system without changing its functionality. Moreover, it is applicable where some part, not not all subsystems of a larger system require frequent maintenance. Re-engineering also involves adding effort to make them easier to maintain. The system may be restructured and re-documented. So the thing is, when actually we want to re-engineer, so when when the system changes are mostly confined to part of the system, then re-engineer is the best approach. So you don't want to change the entire system. You just want to change a particular part of that system. In that scenario, re-engineering is the best choice. When hardware or software support becomes obsolete, it may happen like a particular product is delivered now after performing some changes, or after certain versions of that particular software, the support uh, in terms of hardware and in terms of software is obsolete, and we cannot perform more support to that particular product. When tools to support restructuring are available, so if you have certain tools to perform restructuring, then also we can perform this re-engineering task. So so when we perform basically this re-engineering, there are two important benefits. First will be a reduced risk, and the other is a reduced cost. So a reduced risk means there is always a high risk when you design a new software. However, once you are performing a re-engineering, it means you are not starting from the scratch. You have a system model with you. Now you know how exactly it works because of this abstract level of the system. So re-engineering a particular product is less risky compared to the uh, compared to the software which has been which you want to start from new. So the other thing is there may be development problems, staffing problems, and other specification problems if you start from the scratch. However, when you are performing re-engineering, you don't have to be worried about these things because now you know how exactly the system works. Uh, the next thing is reduced cost. So the cost of re-engineering may be significantly less than the cost of developing a new product. For example, a re-implementation for a particular commercial software, if for which the re-implementation cost were estimated around 50 million, then in that case, re-engineering for successfully performing a re-engineer was just 12 million dollars. So you can see the numbers how the cost can be reduced when you are performing this re-engineering. So in this diagram, we have forward engineering and re-engineering task. So if you see forward engineering, it basically talks about system specification. You go to the customer, you get you document exactly what they need, and based on those software requirement SRS, you design and you perform this. You design the high level design is done, and based on this design, the implementation is performed, and then finally you have a new system. However, when we talk about software re-engineering, we don't start from requirement gathering phase. Rather, we start from an existing software from which we try to understand and what exactly were different designed approaches used to design this particular software, how the implementation was done. So the basic idea is we try to understand, and then we try to transform those information in such a way that which can be used to perform the re-engineering and task. And based on this re-engineering, we can deliver a new functionality of the product. So the main difference between forward engineering and software re-engineering is you don't start from the scratch in software re-engineering. However, in forward engineering, you start from the requirement specification and then you go to the new system. However, in software re-engineering, you start from the existing legacy or maybe the existing software system, and then finally you perform this. You deliver a product, and that this product which is delivered to the customer is actually it's not a it is a re-engineered engineered system. So this diagram basically tells us what exactly is a re-engineering process and how it works. So if you see this diagram, the main re-engineering process is highlighted in blue color. However, the green color which you see, which are there in this diagram, these are the things which are associated with this, with the main phases of this re-engineering thing. So from original program, we start first with this source code translation. So basically, in source code translation, you use some automated translation tool, which helps us to convert a particular program, maybe an old programming language, to a modern version. The second step, if you see, we have from this source code translation, we go to reverse engineering, and we can also go to program structure improvement. However, if you go to reverse engineering, it means the program is analyzed and information we can extract information from it, which is going to help uh, the organization in documenting the functionality of that particular software. However, if you go to the third step, which is program structure improvement, So in this phase, the control structure of the program is analyzed, and of course, it is modified to make it easier in terms of readability and understandability. This step is partially automated. However, this reverse engineering process is completely automated. The first one which we have discussed. The next step is program modularization. So in program modularization, we are more concerned about grouping different parts of the program together, which are more appropriate. And we are also interested in removing redundant programs or functions from our entire software. So in some cases, this stage may also involve some architectural refactoring. For example, the system that uses several different databases may be refactored to use a single repository. However, this phase is completely performed manually. The next step we have is data re-engineering. So basically in data re-engineering, the data processed by the system is changed to reflect program changes. This may mean redefining databases schemas and converting existing database to a new structure. So what are the different re-engineering cost factors? So the quality of the software so basically re-engineering cost factors are in terms we are more focused on the quality of the software to be re-engineered. The second thing is the tool that support the tool support available for re-engineering. So these are the factors which we have to be concerned when we are performing reverse re-engineering. So there should be available tool with the help of which we can perform reverse we can perform this re-engineering. The, the next step is the extent of the data conversion which is required, and of course the availability of expert staff who can perform this re-engineering task. So these are few cost factors which are going to be affected when we are performing re-engineering. However, if you see this graph, so the cost when we are performing this re-engineering, the cost is going to increase from left to the right side of this graph. So when we are performing re-engineering and we are only dealing with source code translation, it turns out that it is the cheapest part of re-engineering. However, when we approach to the right hand side of this graph, and the re-engineering is mainly done on the architectural part, then it is the most expensive task to perform a re-engineering. So changing code will be the cheapest part. However, changing the entire architectural design will be the most expensive part of re-engineering approaches. So the thing is, reverse engineering often proceeds uh, re-engineering, but it is also sometimes worth to note that like the design and the specification of a system may be reverse re-engineered so that they can be an input to the requirement specification process for the system's replacement. The other thing is the design and specification may be reverse re-engineered to support program maintenance. So we need to understand these two things. So these are the two different factors which will be very helpful when we are performing reverse engineering. So program structure improvement, it will be also beneficial for performing a program structure improvement. So maintenance tends to corrupt the structure of a program. It becomes harder and harder to understand. However, the program may be automatically restructured. Conditions may be simplified to make them more readable. For example, this we have the spaghetti logic. Um, if you see this logic, the heating status, we are changing it to off and on based on some condition. However, if we use some structural logic, Then with the help of switch, we can make it more readable. However, we can more the readability of the spaghetti logic can be more be understood with the help of some condition. If we use for example the second one, A is less than equal to B, and C is greater than equal to D, or E is greater than F, something like this. So you need to make this with the help of this program structure improvement. Basically, the old logic is structured in a understandability of the code is simplified. So the next thing is automatic program restructuring. So this restructuring you don't have we don't have to perform manually. However, this restructuring can be done automatically. The quality of the ill programs that we have seen earlier, the spaghetti sample. This is basically done to increase the understandability and ability uh, helps us in reducing the maintenance. So the basic idea is we are going to start first from the program that has restructure, and then from the analyzer, and we are going to use analyzer and graph builder. We are going to have a graph presentation. So different different functions. We are going to draw those functions with the help of automated form of graph. With the help of those graphs, now we are going to generate the programs, and we are going to perform the program, the input for which we started this whole thing. So this is the automated process. So we are going to use, basically we are going to use some analyzer and graph builder tool, based on which we are going to design, have some graph for those programs that we want to structure, and then we are going to use a automatic graph program generator tool, which is this graph as an input, and it will give the restructured program as an output. However, there are certain problems associated with restructuring. For example, a problem with restructuring is loss of comments, loss of documentation, and heavy computational demands. Apart from this, restructuring doesn't help with poor modularization, where related components are dispersed throughout the code. The understandability of data-driven programs may not be improved by restructuring. So there are different module types when we are performing this restructuring. The first is data abstraction, hardware modules, functional modules, process support modules. So data abstractions are mainly associated with the data structures and the logical and conceptual schemas that is being used, and of course their associated operations. So we are going to group all those things together. Hardware modules means all functions required to interface with a hardware unit. So basically, you are going to have certain hardware on which the entire software is going to run. So this hardware. So we are talking about this hardware unit over here. The thing that the third is a functional module. The exactly what the functionality will be, what are the different functionality that particular product is going to perform will come under functional module, and process support module, for what business processes of process fragment this particular software was designed. So so basically, many legacy systems use shared tables and global data to save memory space, and which causes problem because changes have a wide impact in the system. So, however, if the shared global data may be converted to objects or ADT, then the recovering data from the abstraction can be increased. So data abstraction recovery. So we basically we want to analyze a common data area to identify logical abstraction. We want to create an abstract data type or object class for each of these abstractions. Then we are going to provide functions uh, to access and update each field of the data abstraction. Finally, we are going to use a program browser to find calls to these data abstractions and replace this with new defined functions. So next thing is data re-engineering, which we have seen. So basically, this is a process through which the logical and conceptual schemas of a legacy database are reconstructed from various informations such as DDL code, which is data dictionary language code, data dictionary contents, uh, database contents, or the source code of the application program that use that particular software database. So the basic objective is to create or to manage the entire data environment over here. So there are three different approaches associated with data re-engineering. The first one is data cleanup. The data cleanup means the data records and values are analyzed to improve their quality. The duplicacies are removed, redundant information is deleted, and a consistent format is applied to all records. This is not normally required in any associated programs changes. The second is data extension. In this case, the data and associated programs are re-engineered to remove limits on the data processing. This may require changes to programs to increase field lengths, modify upper limits on the tables, and so on. The data itself may then have to be rewritten and cleaned up to reflect the program changes. Third is data migration. Uh, you're migrating the entire data. So data is moved into the control of a modern database management system. The data may be stored in separate files or may be managed by an older type of database management system. The next is data conversion. So data reengineering may involve changing the data structure, organization without changing the data values. Now, the data value conversion is very expensive, and special purpose programs have to be written to carry out these conversion. So this is the data re-engineering process. So basically, the one which is highlighted in blue mainly talks about the data re-engineering process. So we have the data which we want to analyze, and which is given which in stage one we are going to have the entity name, the modification, literal replacement, data definition, and reordering task to do, and then based on which the data reformatting default value conversion validation rule modification is going to be performed, and finally we are going to convert the data. So what exactly you have to remember from this lecture? So the basic goal is to remember the definition of reverse engineering and re-engineering, how they can be used to assess different software related problems. Yeah, thank you. So in the next class, we will see you. Bye.